Hello viewers, this is the second video of manipulation of time series data video series. In the last video we defined the time series and we used some passing functions from lubridate package to turn the character class into date or a POSIX city class. Do you remember that we worked on two data sets? The first data set was on closing share prices of IT company and the second data set was on temperature measurements of IoT temperature sensor data. In these two datasets, we discovered that the date component had a character class. Therefore, we had to change it to date or POSIX city class using passing function. And which passing function did we use? We used TMY function and its variations as per the order of date and time components. For example, if the order goes something like day, month, year, then we will use TMY function. If the order goes like month, day, year, then we will use MDY function and so on. You can always refer back to my earlier video on passing function by clicking the link in the description. Right, so in this video we will extend our discussion further and look at various functions from lubridate package that are used to extract the information from date time objects. For example, if I want to extract only year from the date object or only month from the date object, we can able to do that with various functions from lubridate package that are used to extract the information. Okay, so let's start by generating a simulated time series data with 100 observations. We'll use POSIX city class since we want to simulate a date having a date and time component to it. We will also let the default value of time zone. Remember, for POSIX city class, we will also have to mention the time zone. And we will use normal distribution to generate the values. So here is our data set. We have a date and we have the value, and the date is belonging to POSIX city class. Right. So before we start using any of these functions to extract the information, there is one thing we need to take care of. The date object of time series data must belong to either the POSIX city or date class. This is a mandatory requirement. And if this requirement is not fulfilled, R will going to throw the error. And that's why you see we have satisfied this criteria in our simulated dataset by converting the date into a POSIX city class. Right? Okay. So the first information we are going to extract is the year information. So we will use the year function and pass the date time object as an argument. If you look at the data set now, you will see that it has a new column called year_column, and all the year values extracted from the date are appearing in that column. So remember, we use year function to extract the year information. If we want to extract the month information, let's extract a month out of date time object. So we will use the month function and pass on a date time object as an argument. We'll get a new column called month_column, and as you can see, it got all the month values extracted from a date. There is also additional argument label equal to true, and if I use label equal to true, then instead of the values, the month column will show the description of the months. Right? Okay, by the way, if you are not familiar with the mutate function from the dplyr package, I have created a separate playlist on dplyr package wherein I have discussed all the important functions and how they can be useful in data manipulation. You'll find the link in the description of this video. Right, so let's move on. We will now extract the hour information. Simple, we will use the hour function and As you can see, if I use the hour function, then hour underscore column has all the hour values extracted from the date object. Okay, so now that we understood how to use the EM, month and hour functions, let's apply them on a real world dataset. We will use a flights dataset from Invasive Flights 13 package. Now let's assume that we are analyzing Delta Airlines performance in terms of arrival delay. So here are the questions we are interested in looking at. Number 1, on average, which month has the largest arrival delay? Number 2, on average, which week has the largest arrival delay? Number 3, on average, which day of the week has the largest arrival delay? So we are starting with a month, then we are drilling down to week, and then we are further drilling down to day. Okay, right, so let's start with loading the library Invasive Flights 13, and I'm going to filter out the arrival delay, time, hour and carrier columns from the dataset. So we'll create a data pipeline as below. We will create a new data frame, data underscore flights. We're going to select these 3 columns and filter out the Delta Airlines carrier. And we will start with extracting the month from the data object. Label equal to true, that means month will be shown as a description and not as a number. Right. Now, we will have to group these observations by month and aggregate them into a mean value of arrival delay for each month. Okay, so we will have to use the group by and summarize function from the dplyr package. But remember one thing here, before you use the mean value calculation, we'll have to use na.rm equal to true to keep out the missing values, because the mean function doesn't work with the missing values. By the way, if you're not familiar with group by and summarize functions from the dplyr package, you may like to check out my playlist on dplyr package. We'll find the link in the description below. Right, so this summarized data we will store in data underscore flights underscore aggregate data frame, and we will use this data frame to create the bar chart. We'll make a bar chart now to show the average arrival delay for a month. We will use a geom column geometric layer with months mapped on x-axis and arrival delay mapped on y-axis. We are using ggplot function here and its various layers to create the bar chart. For example, xlab, ylab will give us the annotations for the x-axis and y-axis. Geom text layer will give us the labels, the data labels on top of the bars. And again, if you're not familiar with the ggplot function from ggplot2 package, you may like to check out my playlist on ggplot2 package as well. You'll find the link in the description below. Right, so now we got our chart, bar chart. Now what observations can we make on arrival delays of Delta Airlines? The first observation, when compared to the other months, June and July have the greatest arrival delays. The average delay in June and July is 13 minutes and 15 minutes respectively. What do these negative values tell us? They are negative because flights arrived before their anticipated arrival times. So to answer to our question, if you want to travel with Delta Airlines, avoid traveling in June and July. Okay, so let's try to answer the next question. On average, which week has the largest arrival delay? Right, so we will have to first extract out the week information from the date time object. And for that, we will use a weekday function, wday function. This wday function is used to extract the weekday information from the time object. Again, we will use label equal to true so that we can get the description of the days. The information is stored in new data frame, data underscore flights underscore week. Again, we will have to group the observations by days and aggregate them into a mean value of arrival delay for each day of the week. Remember, we'll have to use any.rm equal to true to keep out the missing values from the mean calculation. We'll store these aggregated data into data underscore flights underscore aggregate underscore week data frame. And we will use this data frame to visualize the arrival delay for weekdays. We'll plot the bar chart with arrival delay on y-axis and date week on x-axis. We'll plot the bar chart with arrival delay on y-axis and days on the x-axis. This is again the same ggplot pipeline we will going to use. And here is a graph that we have. What observations can we make on arrival delays of Delta Airlines by looking at this bar chart? Mondays and Thursdays have the largest arrival delays compared to other days. On average, delay on Monday and Thursday is 5 minutes and 6 minutes respectively. Saturday is an ideal day to travel by Delta Airlines because you can arrive 5 minutes earlier than planned arrival time. Right, so let's dig further into the data and let's check out the delay patterns across the hours of the day now. What are typical hours of the day that one should travel with Delta Airlines? So now we will have to extract the hour information from datetime object. So we will use our function. So our function is used to extract our information. The information is stored in a new data frame, data underscore flights underscore hour. Again, we will have to aggregate the observations. We'll have to group the observations by hour, aggregate them into a mean value of arrival delay for each hour. Again, we have used the same data pipeline. Nothing is changed. Finally, we will visualize the data with arrival delay on y-axis and hours on x-axis. Now, only thing we added in this pipeline is the scale x continuous function, which will break the x-axis in the increments of 1 hour. Right. So here we go. Here is the plot. Few observations we can make from this chart. From 6 a.m. until 10 a.m. there are no delays and flights have arrived ahead of schedule. Right, so this is the ideal time to travel from 6 a.m. to 10 a.m. But the arrival delays starts creeping up from 11 a.m. and they go at peak at 9 p.m. On average, you can save 11 minutes on your commute if you travel at around 11 p.m. And there are no Delta Airlines flights scheduled from 12 a.m. to 5 a.m. Great, so let's summarize. Lubridate package has various functions to extract the information from datetime objects. Following is the list of functions one can use. If you want to extract the year, then use year function. It will give you the result as a year value. If you want to extract the month use the month function. It will give you the month value. If you don't want the value, then assign label equal to true. It will give you the month description. If you want day, use day function. If you want hour, use hour function, and so on. These functions are from the lubridate package. You must have observed are super easy to use. The other good part about these functions are that they are so intuitive that you can figure out immediately what they are doing. Great, so I sort of given you the template to try out different ways of extracting the information from the time series data. You can use this template on the other data sets. For example, you can pull out the sales data from your company database and use these functions to explore the sales patterns. Or you can go to the Kaggle and pull out any time series data and try out these functions that we have learned. Remember, practice experimentation. Practice experimentation. This is the only way you can master the art of gramming. Thanks for watching till end. Thank you very much for watching this video. I will see you soon.